All right, we are going in Chapter 2, Lesson 1, called Relations and Functions. If you notice, there's a little typo on this guy. It's not 12.2, it's 2.1. So this is Chapter 2. So we're going to just take a look back and kind of review what is the difference between a relation and a function. Remember, a relation is just a relationship between two numbers. So generally, we look at that as like an ordered pair. 1, 2. That's a relation. And we can get a whole group of relations that they each have a relationship to each other, but the points don't necessarily have a pattern between them. But when we have a function, we have a special relation. So a function is a relation in which each element of the domain is paired with exactly one element in the range. So here we can see this. Each element of the domain pairs to exactly one unique element of the range. So we can see these arrows pointing from 1 goes to D, 2 goes to B, 3 goes to A. An onto function, so this is just another, type of function. So this was 1 to 1, and then we have onto function, which means that each element of the range corresponds to an element of the domain, which means that sometimes the range is repeated. Both 1 to 1, and onto. So each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. So that means literally it's 1 across, and there isn't kind of that extra one sitting there, so that's why this is 1 to 1 and not both. So it's just combining the two. The way I like to describe functions, you can think of it as a kind of a machine, but a really easy way to describe this that I found in one of the math classes was to think of baking a cake. So if I put all of the ingredients in to make a chocolate cake, and I mix them all up, I put them in the oven, and I get a chocolate cake out. So input, output. Tomorrow, I do the same thing. I'm going to put all the same ingredients in that bowl, mix them up, put them in the oven, but tomorrow I get a vanilla cake out. Well, that doesn't make any sense. I put all the same ingredients in. I should get the same thing back out. So it's kind of a silly way to think of it, but it just helps you make that understanding. If I put something in, I should get the same thing out every time I put that same input in. But I shouldn't be able to input the same thing and get a different range out or get a different output. That if we look at this one, though, we have the same idea here. So like 3 and 4, this might be that I put all the ingredients together to make a chocolate cake, but they're slightly different chocolate cakes. So it's just two types of chocolate cakes, so slightly different ingredients here, but I still get a chocolate cake out. So it's just more than one way to bake a cake there. So that's the idea, to relate it to my silly little story there. But the main idea here for a function is domain is not repeated. Range can be repeated in some of the situations, but domain cannot be repeated. All right, let's scooch down here. If a relation is made up of a set of individual points, it is a discrete function. When a domain of a relation has an infinite number of elements and the relation can be graphed with a line or smooth curve, the relation is a continuous relation. So it's just the difference between discrete means we didn't connect the dots. Continuous means we did connect the dots. So just two descriptions, what we call these. Whoops, I didn't mean to move to the side there. All right, and then we have a test. This is a visual test, so if you already have a graph or if you have points and you graph them, you can use the vertical line test to determine whether a relation is a function. So the vertical line test, as you can see here, is literally a vertical line straight up and down, and we graph it across our curve, or if it's a line, we could do it on this one too. So I can draw a vertical line here. As long as it only crosses once, so both of these only cross once, that is a function. If it crosses more than once, that's when it fails this test. So when I can draw a line anywhere on this graph, it's only going to cross it one time. So it doesn't matter where I draw the line. But if I look at the second one, the vertical line crosses 2 times. And the only time it doesn't cross 2 times is right here on the end on the vertex there. We can call that the vertex. So I can draw it anywhere else. So if any vertical line fails, it fails the test. Just because one of them passes doesn't mean it passes. As soon as one fails, it fails the test. And it can't be over here where the graph is not. That doesn't count. It has to be on the actual curve or the line. If you're looking at a discrete function or a discrete relation, what you want to look at is, does it cross more than 1 point? So this one, if I did it only crossed the 1 point, that's perfectly fine. If we did in fact have another point, like say right here, underneath, even if it fails only in that one spot, it crossed 2 points here, it failed the vertical line test. So you can also use that on a discrete function. All right, let's scooch to the next page here. I think I need to scoot up because I think there's an example. There is. All right, state the domain and the range of the relation and then determine its function if it is a function. If it is a function, determine if it's one-to-one, onto, both, or neither. So domain and range, you're going to have buttons to push on Alex to do this. So domain, and you should have a little button off to the side so you can press this and it'll put like a box in here and you just start typing. Domain means your x values. We're just going to list them. So we have -6, -5, -3, -1, and 6. So it goes from least to greatest. Range, and I'm just going to switch my colors here, is same thing. You push that little button there. And it's the y values this time. So remember, domain is just another way to refer to the x values. Range is just another way to refer to the y values. So we have -1, -9. Oh, these aren't quite in order. I'm gonna scooch them around so they're in order. So -9 is smaller than -7, then -1, and then 7. If you notice, I didn't repeat -9. So what we're looking at is, this is left to right. So if I'm looking at a graph, I'm going to have to go to the left 6, so left 6 and right 6. So this tells me how big my graph needs to be really quickly. And then I'm going to go down to -9 and I'm going to go up to 7. So again, it tells me how large my graph needs to be, kind of really quickly looking at domain and range. I just realized I left the E off of range. So it's kind of a quick reason why we want to look at domain and range. And it can also help us see if it's a function and what type of function it is. So I kind of like to do the mapping, which was on this page. This is called a mapping. So let's go ahead and look at mapping. Just because it does the arrows kind of nicely. So here's my domain, here's my range, and I'm going to put my numbers in here, and I'm going to color code them so that my domain is here, like this. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I wanted to make sure I didn't forget any. And then we have -7, -9, -7, -1, and 7. And then what we do is we literally point. So -6 belongs to -1. -5 belongs to -9. -3 belongs to -7. -1 belongs to +7. And then 6 also belongs to 9. So if we kind of take a step back and we look at this, 1-to-1 means that it literally goes 1-to-1. Onto function means that none of the x's are repeated. Remember, that's not allowed. That would actually break the vertical line test because that means the x's are repeated. But the y's are repeated. That means 2 of the x's go to the same y. Remember, we had 2 different ways to make a chocolate cake. We still get a chocolate cake. So this is an onto function because 2 of them point at -9. So this would be onto function. But yes, it is a function. None of the domains are repeated. So we'd say yes because each element of the domain each element of the range corresponds to an element of the domain for onto function. So make sure you select the correct wording there, which is they're literally just using the wording for the definitions up here. All right, let's go ahead and look at this next piece. We're going to use equations can be written in function notation. The equation y equals 5x minus 1 can be written as f of x equals 5x minus 1. So remember, this is just another way to write y. And what it literally is telling us is that it is a function, and they can give us values to plug in for x. So it's just another way to write our equations here. So if we have f of x equals 2x squared minus 8, find the value of, we have two different equations here. So let's do the first one. We have f of 6, actually I'm just going to use there, f of 6 equals, so it's 2, instead of x, they're asking us to plug in 6. So 6 squared minus 8. And now I'm going to go through order of operations. So f of 6 equals, I'm going to do my, there are parentheses here, but remember these are just parentheses that show multiplication. So when it says parentheses in order of operations, it means literally something to do in the parentheses. There's addition, subtraction, multiplication, division within the parentheses to simplify. So there's nothing to simplify in there, it's just a 6. I can move to exponents. So this is going to be, you can do the dot 36, or you could leave it parentheses, it means multiplication here. Minus 8. So now I can do multiplication or division in my order of operations there. So 36 times 2 is 72 minus 8. F of 6 equals, so 72 minus 8, we'd have, let's see, 64, I believe. So we get 64. So this is another way of saying this is if I plug in 6, this is my input, this is my output. So input, output. And that's the same thing when you're looking at your x and y coordinate. Input is x, output is y. So if I put in 6, I get out 64. All right, let's look at this one. So this one's a little different. Now they're asking us to input 2y. So this is my input. And we have to see what our output is. So now it's 2. Instead of x, I'm replacing x with 2y. Like that. So that's definitely a common one where they ask you to replace it with a monomial. All right, remember when I square this, I need to square both pieces. So f of 2y equals 2. 2 squared is 4. Y squared is y squared. Minus 8. Now I can multiply. Equals 2 times 4 is 8. Y squared minus 8. I can't simplify that anymore, because this 8 has a y squared and this 8 does not. So this is my output. And on the computer, they're probably not going to make you type in the coordinate. What they're going to have f of 6 equals, and you just type in 64. And they're going to have f of 2y equals, and you're going to type this guy in. I know you're going to have different examples, but that's the idea there. All right, let's keep moving forward. Oh, nope, that was the end of section 1. So I will see you in section 2.